Hello guys, welcome to my game dev channel. My name is Alex and today I'm starting a new tutorial series about procedural generation. On my channel there were several videos about procedural generation in the previous period, but they were removed because many reasons. So I decided to restart this series because it's interesting, it's useful, and there are not so many information on the internet about procedural generation. And in this first tutorial series, I wanna show you how I achieved this result. Let's see. So, as you can see, we have the procedural world looking, I suppose, not repetitive, looking natural enough. Let's remove exponential fog to see the result better. As you can see, we have valleys, we have mountains, plains, flat regions, plateaus, some kind of lakes, I suppose. So different peaks. Here we see valleys. For example, here we can, in future tutorials, generate some rivers, for example. We see the oceans, the seas, lakes, so on. Different beautiful long like flat regions, as I said before. Ridges, mountain ridges, some swampy plains, for example, as you can see here. This beautiful like erosed terrain stuff, these beautiful hills. So, as you can see, there are a lot of beautiful natural looking views. I suppose I don't know how to say it in English, but never mind. It looks good, isn't it? I suppose much better than most of the terrains you saw on YouTube. But how did I achieve it? So, actually, it's not really hard to do. But before we start in this tutorial, I wanna say some words about the procedural generation itself and about this series. I'm not a genius and I'm not a professional at all, so I don't know about some stuff. For example, I'm absolutely zero in materials, and I don't know how to make it looks beautiful. If you know, you can say me. I just know how we could achieve it. Maybe, maybe not. The other thing is problems with the procedural generation itself, because there are deep problems in procedural generation which we have to fix in the future tutorials. But actually, for now, I don't know how to fix some of these problems. For example, the problem of randomness of the noise. As you may know, noises are just a bunch of pseudo-randomic variables, values, but what I mean, actually the range of noise should be between -1 and 1. But in practice, for example, this range will be in range of -1 to not -1, -0.7 to -7. What I say? Fuck. -0.7 to 0.7. And the range between -1 and -0.7 and 0.7 to 1 will appear more rarely than the range between -0.7 and 0.7. And why this is a problem? Just because these rare ranges are actually used in our code, We use them to determine some points of height, some other values. So the problem should be fixed. But actually, I don't know how to fix it. I suppose it's related with some Gauss filters or maybe a box filter, I don't know. But we have to fix it. And if you know something about it, just say me, please. So, the other thing I wanna say is that this tutorial is not aimed on showing you actual parameters, actual code which we wanna use in each project. I just wanna show you how to achieve such similar results in your projects, how to achieve something beautiful and nice, and how to manage it. So the different ways to achieve the result. I don't want to show you the exact steps. I suppose you understand me. So let's start the tutorial. First of all, as you can see, the world generates procedurally and it's endless world. How did we achieve it? Let's open this personal game mode, third personal game mode, and you can do it in C++ if you want, but I actually did it in Blueprints. Why not? We'll talk about Blueprints in C++ later a bit. Let's see. First of all, event graph. What we see here? We see here, before starting, I really recommend you to press on this icon and check show access specifier in the My Blueprint view to see these access specifiers. It's really useful in real projects because we wanna manage this, okay? We wanna make some variables private, some functions private or protected, and so on. We don't want to show everything in global view, if you understand what I'm talking about. So, but never mind. Let's see the code. As you can see, on event begin play, I stop seed. Seed is random, but actually I didn't use it in my code because I work with C++, so we will see it later. Then I spawn new chunk. This is function the most important here, but we'll see it later. Also I have custom event update chunks, where I just destroy chunks out of range and spawn a new chunk when I call this event. And every tick I check if my function getChunkQuartz equals to the last quartz saved in the variable last quartz. If it is just nothing here, if it's not, we set our last quartz as our data from this function and update chunks. Update chunks is our custom event, as I said. Let's see this function getChunkQuartz. It's really easy. Here we get player controller, that then get controlled pawn, get actor location, and from this get actor location we divide it by chunk size. Chunk size is a float variable which should be equal to multiplication of our actual number of vertices per row and or per column multiplied by grid spacing, space between these vertices. Okay. For example, we have 10 vertices per row and the grid spacing is equals 100. So chunk size should equals 1000. Then we round this float x and y variables and return them as integer. Last quartz xy is just an integer vector variable. And that's all here. Let's see spawn new chunk function. Here we have two loops. That's why I recommend you to do it in C++ because loops in Blueprints just sucks. It's not really optimized and your code will freeze. What we see here. First of all, we should create render range variable. it's integer, and in my case it's equals 20. But if you will try to reproduce my code in blueprints, don't even think about 20, because 6 is just enough for blueprints. Because if you set bigger number, larger number, I don't know how to say properly, sorry for my English, it just sucks. So if you set biggest number, your game can crash even. So here I did this multiplied by -1 because we want our chunk has its origin in the center of the mesh, actual mesh. So we have to loop this render range from -20 to 20. So for x and for y. Then we set chords variable, which is integer vector, and here we get chunk chords. Add our actual x and actual y, and set here. And then we should check if our chunk chords contains chords. I mean not contains, because we want to go from true. And moreover, if our let me see. So I will not say anything about this code. Actually, I just try to explain what it means. This code is needed because we want to let's see in the game, because we want to move our chunks, spawn our chunks in a circle, because we don't need actually these chunks at the edges of this range. We will never see them in the game, but we want, for example, to see everything in front of us, just in front of us. Okay, so this code just helps us with it, and you can just copy paste it, and you will achieve something like that. So your spawn region will be like a circle. Okay, then if everything is okay, we just spawn new actor. In my case, I spawn my blueprint actor based on my C++ class, and as x and y coordinates, we get our chords variable and multiply it by chunk size, which is actually 1000, and then we add it inside this oh fuck inside this array. Actually, we can optimize this code by just using add unique or using map dictionary. Okay, but do it by yourself. I don't want to reproduce it. Let's see destroy chunks function. Here we have one for each loop. We actually get our chunks chords array and loop through it. Here we get x and y multiplied by chunk size, and check if the distance between the actual chunk more than between the actual chunk and our actor, our character, is more than chunk size multiplied by render range. So I mean, if our chunk is out of range, then we have to destroy this chunk actually in the game. We can not destroy it, but just hide. For example, because it's more optimized, I suppose, than destroying and respawning it, we can just show it again when we come back, but it will cause us a bit more code here. And I actually don't want to write any code here. And then we just remove this chunk from our array at the given index and from another array. So that's all for this class. Let's close it. Save all. Now let's see our My Blueprint class, which is actually really similar to what I did in C++, because someone wants to achieve the same result in blueprints, but I don't recommend really. Before starting, let's open our project settings. Don't project settings, close it if you open it. Open plugins, and here type fast noise. As you can see, I applied my fast noise generator plugin. It's free on Marketplace, you can find it. And it's available for the 5th version of Unreal Engine, so you can use it in previous version like 4, Unreal Engine 4, and as well in the 5th version. So apply it, restart the game, so on, blah blah blah, and now we're here. Let's open event graph before. Here there is nothing, you can close the event graph. Let's open construction script. Fuck. Spaghetti. Here I have macros. This macros is called noise init. Here we should construct object from class, type just construct object from class. And as you can see, we have such object from class. And let's find here path noise I said, wrapper, fast noise wrapper. Then set this noise in a variable. I have, and for each new noise you will use, you have to repeat this stuff. So I have 5 noises here actually. And here I have setup function. Here I get my peaks noise, my erosion noise, my continentalness noise. We talk about it a bit later. And I set up them. Here you can use noise types as you want. Just experiment with it. Don't copy paste my code. Here is frequency, really important parameter, because with frequency we can understand how often we will see some mountain peaks and how often we will see some valleys, hills, and so on. Octaves as well, really important parameter as well, because it helps us to make more details for our terrain. And the other parameter is for other noises. Also we can change this fractal type, because sometimes we want to use more, like, you know, reached noise. Sometimes we not noise. Actually, fractal type is used for octaves to repeat this octaves, okay? And different fractal types makes the octaves looks differently. Usually we use FBM, but sometimes we want to use, for example, below, quintic, ping pong, or something like that. So also here I get my seed from game mode. Is actually needed, because if you will get random seed inside each chunk will have different seed, and so you will not see beautiful terrain. You will see a bunch of chunks with different noises. So you should apply this seed in some other function, in some other actor, and just get it to make sure that all your chunks will have the same seed. Here I just set constant seed. You can repeat it if you want to see something like my terrain 1133, and I just add some different values here to make sure that different noises will have different seeds. Okay, based on the main constant seed. Okay, let's close it. Don't look at this. Here we have the function which actually is in basic blueprints. Grid mesh welded, create grid mesh welded. Here I have variable map size, which is actually number of vertices per row and per column. And grid spacing. I don't have any variable here, I just set it exactly here. And as you can see, here I have 11, not 10. This is because of the looping method, because we can compare it strictly less or more, or just less and or equal, or more and equal. You understand, yeah? So we need to check it. If you set 10 here, maybe border between different chunks, like say properly, you will not see the border between different chunks, okay? So then just add 1 point to it. Set 3 variables, triangles, vertices, UVs, and then just because we can't say this function to apply our noise to mesh, we have to loop again from blueprints, get our vertices variable, and here let's remove everything here because it's just useless. What we see here? Here we get array index and set it in variable for convenience, and set our position y and position x variable. It's really important to set these variables, because if we just will pass this x and y inside our noise function, we'll get the same noise for each chunk without offset. So we have to add our chunk actor location to this x and y to get the position of this chunk in the world, actually, not in local space, okay? And then we can add our vertex color. And here I want to say that's the next thing. So why do we need vertex color? Just because, as I said before, I'm not really good at in materials. I'm not really good in GPU graphics. I'm not really good in everything at all. But I suppose we can use vertex colors as mask then to blend the textures between each other with this mask. But there is a problem here again, because we can't use infinite amount of colors as mask, because we have only RGB and A channels, so it's about 10 or 12 combinations of colors for our biomes. If we want more biomes, so we should do something with these channels, and I don't know what, you understand, yeah? So, for example, we can use red and blue channel and blend texture grass and texture sand between them, and take, for example, blue and pink color and get channel of it and blend, for example, snow and grass between them. But I don't know how to blend them properly, okay? I just can understand that we can get this vertex color as our alpha, and then lerp to textures between each other by this alpha, but I don't know how to improve this code. The other way to paint our terrain actually is to get Perlin noise values, pass them inside the material with set scalar parameter of material here, and then use these values to generate texture of this noise. So we can just lerp between these values, and as alpha we can take, for example, world position vs, and just put this value as a texture, and then we can paint this texture with some colors based on the code we will use for our biomes, okay? We can repeat the code inside the material, inside shader. But I don't know, actually. I will think about it later. For now, we have to generate terrain itself, because it's not so easy, as you can understand. But if you know more than me about materials, you can help me with it. I just give you an idea, okay? So here we can use this add vertex color to paint our mesh. For example, we can check if, for example, the level of our terrain is less than 0, for example, less than 100 meters, we can paint everything as blue color because it's ocean, for example, just to see the ocean line, okay? Actually, to paint ocean, we have to add inside the sector another plane or another procedural mesh, which actually will represent the ocean level, and we can grab it and change its z value or vector value, okay, to understand where exactly the sea level will be. Okay. Then we set array element inside vertices array at the given index, and we get just simple x and y here. Don't use position y and position x for that. And at z we get this calculate height function, which is actually really interesting. How exactly we achieved this beautiful terrain? How exactly it works? Let's come back to the viewport, and here we have 3 interesting curves. I actually have 4, but it's not important. Let's open this 3, and here what we see. We have 3 different curves. Actually, I get this idea from Henrik Knigberg, I suppose. I don't remember, I'm sorry, the name of the author, but it's a really good man. It's a developer of Minecraft. So, in the last versions of Minecraft, as he said, they use new technology to generate noise, and I understand them, because we can achieve the same result with mathematics. We can use different exponentials, we can use power functions, we can use domain wrapping, multiplying millions of noises between each other, adding them to each other. So we will achieve something like that, but it's too hard. It's too hard to calculate. It takes many time. It takes many view of us, and we can just through this project remove it. Let's say removed. But with curves, we can control our height actually really easy. Not really easy, because actually to achieve something like my terrain, you have to pay. You have to spend a lot of time, much time. I actually spent about a week to achieve something like that, because to control these points, we can control these points easily, but to achieve something good, something beautiful, something interesting, we have to calibrate them really properly, okay? But it's still more easy than just using 5 million of different noises about and mathematical algorithms and functions, okay? So here we have 3 different noises: continentalness, erosion, and peaks, as you can see it in Minecraft, for example. If you press F3, as I remember, and there are several values like C, E, and PV. So here I use continentalness, erosion, and peaks and valleys, so just peaks. And what's the beauty of it? Continentalness should show us how far from the sea our terrain is, or how far from the shore our terrain is. Actually, if the value of this noise is less than 0, or actually less than minus 0.17 or 18, all these values behind this minus 0.17 are about ocean. As you can see, we have really not smooth lines here, and a plateau between -4 and -2. And actually it represents us our sea level. And as you can see, the vertical line here represents our height. As you can see here, these points where we have some plateaus and some hills here and a really smooth upline, it's higher than 0, but everything else just lower than 0. And it helps us actually to get really interesting height in our terrain, because we have seas, we have oceans, we have rivers thanks to this node, thanks to this curve. We have actually beautiful plateaus, we have actually smooth uh, upstairs. I don't know how to say. Never mind. Just we have beautiful terrain. Let's stop on it. But actually, the only one curve can't make us be glad to see this terrain, because we have no peaks, we have no valleys, we have really repetitive terrain. But what to do? Just add another noise with another values, for example, different amplitude, different frequency, different multipliers. You can multiply and add some values as you want. You can just, for example, let's come back here. We can get this noise, which is erosion actually, with really low frequency and really high amplitude, with 3 or 4 octaves instead of 9 octaves for continentalness, for example. And we can multiply it by different multipliers. We can add different values to it to achieve more interesting result here. I suppose you understand me. So do what you want. Just try to achieve the terrain you wanna look at, okay? Let's see the erosion. Here, our curve, because actually, after we get this noise value, we have to multiply it by this, don't multiply it, just we get this value from noise and pass it inside get float value function as time. Time is our horizontal line, as you can see. And here is from -1 to 1, because our noise is in range from -1 to 1. And as I said before, by the way, that's why we have to smooth our noise gradient to achieve more wide range, okay? Because actually we will see the values between these in this range more often than in this range, okay? And we want to fix it. Let's come back to erosion. Here you see my erosion. Let's see here. As you can see here, I have -1 and 1 again as our horizontal line. And by the way, I just make a circle. I will show you how. Well, here you can see, choose how the curve is evaluated if sampled before the first K. Circle. It's not needed actually, because we will never achieve results more than -1 or 1. Less than -1 and more than 1, okay? But I did it. Also, to calibrate these values more properly, set off these two buttons here. Toggle time snapping and toggle value snapping. We don't need them. So now we can manage these points and set values as we want. Don't repeat these values and don't copy it from my curve. Try to do work by yourselves. Just change some values and see how it looks. Change some values, see how it looks. Repeat 1000 times and you will achieve something good and interesting. Here, as you can see, the logic is easy. Our erosion is actually almost higher than 0 instead of the exclusive this point, okay? The other points are higher than 0. And actually the logic is here looks like that. If erosion is less than 0, then we want to to make height. Give me a second, I will check the word. I'm stupid. So we want the value rising up if the value of noise is less than 0. But because as less the erosion, the higher the terrain, okay? The much the erosion, the terrain will be more flattened, more like hilly or even just a flat, okay? And as you can see here, we have flat in the range of between 1.1 and 0.6. Here we have a peak with plateau, and here we have some not rising but decent. Ooh, it's hard to speak English actually. So let's open our peaks curve and peaks curve as well related to our noise, another noise. Actually, we have 3 noises and 3 curves here, which we just add to each other. Let's see our peaks. Here we have 0 level here, and the only one point is less than 0, the other higher than 0. And this curve represents that if the value is more than 0, if the value is more than 0 of noise, I mean, then we will achieve some peak like this. But if the value is less than 0, we will achieve valley looking terrain. So thanks to this curve, we can achieve something looks like river valleys or even high peaks of the mountains, okay? And actually we can achieve really good results with these curves. Then afterwards we add them to each other, and inside the construction script, as you can see, I put this final height value as z. After we set our vertices, we can, let's remove this fucking notes, we can calculate tangents for mesh. This function is needed because if you want to achieve beautiful looking normals, beautiful looking specular and roughness, if we want to see beautiful textures on our terrain. So we get normals and tangents from here. It's really important here. Then we create mesh section. By the way, I forget about it. We have to do something. Let me show a bit later. And then we create dynamic material, and here we can also drag this here and set scalar parameter value for our, not for collection but material. I choose not proper node, but the same is for materials, and we can pass them our height value or something. So here we apply all our arrays, and that's all. I mean, actually that's all. Let's see the material, by the way, I use, because vertex colors will not work if we don't see any, if we don't put a vertex color inside the material. So here we get vertex color and put it as a base color. Don't look at this. It's my experiments. Let's close it, and as I promised, let's open plugins. Here type procedural mesh component. I suppose it should be checked by default, by if it's not, just check it and restart the engine. And then inside our actor we can add a new component, procedural mesh component. And a really important thing, we have to put this procedural mesh as a root. So remove default thin root and put this procedural mesh as root component. And also we can check out our shadows here. We don't need shadows for procedural mesh because it will be glitching. It will be not beautiful. So as you can see, cast shadow here, the default value is true. We should check as false. Okay, let's see now my C++. Before it, I wanna show you how to add curve. By the way, press right mouse button here, find miscellaneous, and here find curve. As you can see, it's here. Then, if you started Blueprint project and want to use C++ classes inside it, make sure you install the right version of Visual Studio and all SDKs and additional libraries are included in this version. You can find videos on YouTube what you want to include inside your Visual Studio, because if you will not achieve this, it can broke your project. Okay, make sure you can create new project with C++ classes without any errors and so on. Let's click Tools here and click New C++ class. Inside Blueprint project, you will not have any C++ code or classes or source code, and you will need to add it. So before starting, click here, New C++ class, add anything you want, then close the engine, open the project, click right mouse button on your app project file, and generate Visual Studio code. After it generates codes, you can open the project, it will build up and the project, and then you should see here C++ classes folder. Open here and you will see here something like that. You will see that class you add. Let's open it. Here, as you can see, I have a bunch of code. If you never see C++, I will try to explain you what the fuck is here. Here we see chunkmesh.h and chunkmesh.cpp. Chunkmesh.h is just as in blueprints. Let's open blueprints, for example. Chunk.h is our sidebar where we can create new variables, functions, macros, some other stuff, add our components like procedural mesh component or material component or noise component, and so on, so on, so on. So .h is our header where we can add our functions and so on. The implementation of these functions actually happens in CPP. And here, as you can see, I have a lot of code here, which I actually don't use in project, so don't copy it fully. I will show you only this code which you have to add. But before, we also have to create our header file. We can create it here. My project now, let's close it. So you can create it here. Just press right mouse button on some folder, click add, create element, and choose .h header file. But in my case, I just created a class inside Unreal Engine and remove CPP file because I don't need it, and just change the header file. I create empty class, by the way, and change empty file, change header file as I need it. So let's see how it looks. Here I add this great amount of code. It's actually the library of noise which I use. This is the same library as we use in our plugin, but it's more convenient to use actually the libraries in the plugin inside C++, so I will put a link to the description below. If I do forget about it, just type fast noise light and you will find this actual library for C++. Then you copy all the code you see here, create fastnoiselight.h file and put all code here. Then we could just open our chunk mesh.h, which is actually my actor class. It's CPP actor class, public class by the way, but never mind, you can make it private because we don't want to see this file in any place. So here we see something like this. I add procedural mesh. First of all, include procedural mesh component here. It's really important because if you don't do it, you can't use it. You can forget about it for now because it's for our multi-threading. I will show you in future tutorials how to achieve this result. And then here I add several classes. Fast noise light class, procedural mesh component, material interface, and I created structure procedural mesh tangents because it's more convenient to work with this structure. If you will get some errors, just try to add some includes here. I don't remember which include works with material interface actually, maybe not any one, but I'm sure you have to include procedural mesh component to use this class procedural mesh component. Then here I created several variables with properties. Properties needed to set some specific parameters for our variable. For example, if we set edit anywhere, you can edit this variable anywhere inside blueprints, inside some viewports in your engine. Blueprint read write means you can read and write this variable. Category means that this variable will be in that category. Okay. Here I created float, integer, float variables. By the way, mistake. It's not good. Forget about this runnable thread because it's for multi-threading. Has thread as well, static and out thread integer. So you have to apply only these variables I show you from 35 line to 45 line. Here inside the protected area, protected is access specifier. I recommend you to put all your variables like material interface and fast noise light here. And here I use fast noise star continentalness erosion peaks. I create actually 6 noises here, but I don't use volley, so you can remove it. It's not so important. Then I don't use any of these functions yet. Here I create, also forget about TQ, it's for our multi-threading again. Here I have in public access specifier 3 curves. curve, float, star and name of your curve, C curve, E curve, P curve, inside category terrain curves, and I can edit them anywhere. It means that if I open our blueprint actor which represents our C++ class, I can set them inside here. Forget about initial calculations, it's for multi-threading. Here inside private access specifier I created C arrays. Array, it's just arrays of vector, integer f, vector 2D, and structure f procedural mesh tangents, and f color as a vertex color for our procedural mesh. Also I applied procedural mesh component header and component, and as name I set procedural mesh. Here I applied several functions. Void generate mesh data. You can copy paste it. Float calculate height. It's the same function as I show you in blueprints for calculating height. Actually, to add in multiplications of curves and not multiplications, just curves which get noise variables here. And function void setup noise, because in this library we don't have such function. We should apply all noise materials by ourselves, but I don't want to do it like 5 million times, so I created this function for convenience. You can repeat it. Then forget about all this stuff. Is for multi-threading, blah 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 blah. What we see here also in the end, by the way, not in good place. I should put it, for example, here inside the main class. Smooth noise. I don't use this function. It's just my experiments with this algorithm to smooth the noise values, but it's actually don't work properly. This algorithm is a box smoothing, box filtering algorithm, and I suppose it will work, but it doesn't. So, what the fuck is this? Okay. Okay. And by the way, here you see class load voxel is task is for my multi-threading. I copy pasted from some other project of the other man. Don't look at this. It's just some bunch of useless code which I actually don't use in project. I just work on it. And here, let's open our chunk mesh CPP function, not function, but file. And here we can see some things. First of all, I include runtime engine classes engine.h directory, I suppose, to use print stringing, because in C++ without this include we can't print string on our screen. Also, I include procedural mesh component.h and kismet procedural mesh library.h, and also I include my fast noise light.h, which we created before. Remember, library for our noise. But to use procedural mesh.h, actually we have to open file name of your class .build.c#, and here inside this file we have to add in public dependency module name set range this string procedural mesh component, and I suppose that's all, because without it you will not you can't use procedural mesh actually. So then we set default values here. First of all, you can check, you can delete or remove this line, because it causes problems with performance and optimization, and if you don't use ticks, you can just remove it. I will not, because maybe I will use it. Procedural mesh equals create default subobject u procedural mesh, and here I set my name of my procedural mesh here. Set root mode root component, I just set my root component, my procedural mesh as the root component. Here I use async cooking, just experimental function. I actually don't know. You can remove it. It's optimal, okay? Optional, I mean, not optimal, optional. Here I set cast shadow false, because we don't need shadows here. And then I set our noises here. I create new object of class, continentalness, erosion, peaks, valleys, temperature, noise, moisture. Temperature and moisture I will use later for biomes. Valleys I don't use actually. Peaks, erosion, and continentalness is the same object of classes as I used in blueprints. Here I have construction, but I don't actually pass code here, because before I choose curves inside actor, I will not open it. I could not open it, because the game will crash. Because without curves our function doesn't work, and there are many errors then, and but our construction script tries to generate our terrain here, okay? So don't use it, actually you can remove it. So that's why I set up my noise inside begin play. Here I use my function setup noise, where the parameters, as you can saw here in .h file, fuzz noise, star noise, integer seed, float frequency, and int octaves. I have 4 arguments here, and I pass these arguments here as well. For example, continentalness is my noise, 1133 is the same seed as I used, constant seed as I used in blueprints. So this is our frequency and this is our number of octaves. Then I get continentalness and set fractal type. You can put dot, I suppose, instead of this arrow, but it's not important. Which is important is that we use fractal type FBM almost for every noise instead of peaks here. In C++, for peaks I use fractal type reached to achieve more beautiful result, okay? And I recommend you to use the same thing here, because the combination of different fractal types and noises will give us more interesting results. Just experiment with it. Then I reset vertices, triangles, UVs here. It's the same as clear or empty, I suppose. Not clear, I mean empty. But as you can read here, same as empty, but doesn't change memory allocations. Then I generate mesh data here. Generate map data is our function to generate actual our mesh, and here here also I you implement calculate tangents for mesh as a source of Kismet procedural mesh library, and calculate pass vertices, triangles, UVs, normals, and tangents here to calculate tangents for mesh. And then for my procedural mesh, I said create mesh section. I use method create mesh section, I mean, where I pass all my arguments here. You can like to say how to say. You can look at this function and see all the arguments we have to pass here, and just pass them here. And then I just set material. Actually, in .h file, I set my uMaterial interfaces with name material here. uProperty edit anywhere as well. We can change this material inside our blueprint actor. And that's all for this begin play stuff. Let's see our generate map data function. Here, as you can see, I create new local vertex variable equals 0 and create 2 for loops where I set my position x and position y values as get actor location x plus x multiplied by grid spacing. It's important to multiply it by grid spacing, because without it our actually points, our vertices will not be applied on our noise, and actually chunks will be applied for noise, but not vertices of this chunk. Then we set our float height variable as return value of calculate height function. Then I add new vertices, new vertex inside vertices array, and pass x multiplied grid spacing, y multiplied grid spacing, and height as z value. Height here, as you can see. Then I add UVs. I add new UV to make our textures looks good. And here I just pass vector to d variable inside, and inside it I pass x multiplied by UV scale. This is the variable for scaling our textures, and for y is the same. Then I check if height is less than 1000. I color in my vertices in blue, and Otherwise, I color them in green. Then if x less than map size, which is actually the number of vertices per row column, -1, and y less than map size -1, then I add triangles for actually this 3 triangle means that triangle in coordinates 0, 0, in here I use 0 plus length uh, of the chunk and +2 to achieve right up edge, right up edge. Here is left up edge. Here is another time right up edge, then left down edge, and right down edge here. So I create actually a rectangle here. And then I increment my vertex. I incrementing it after. So 2 pluses is here, not before the variable. And also it's important to use this branch if node, because without it we will connect last vertices in a row with the first vertices in the second row, and we'll achieve not really good result. We will see vertices behind from both sides, and from the other side they will be not correct. Okay, if you do everything right, you will not see anything from the bottom of the mesh. Okay, you will should see just a sky and maybe God in race, but not anything else. Okay, so that's all for this function. Let's see calculate height, and here I use 3 floats, CEP, and get actually noise value here multiplied by Z multiplier. I use this Z multiplier to make sure that the value will be the float. Actually, Z multiplier equals 1.0 float variable. It's important because sometimes noises doesn't work because we put integer values, not integer, but he can't see float value here. We should multiply everything by float value, even by by 1, float 1. So values should be floating, okay, not integers. And then I commented my debug message. You can copy paste it from my code to make sure that values works good. Add on screen debug message, and here -1 means that each new string will be will not remove the previous one. Then we put here the time, for example 10 seconds display time, then we put color for this message, and then we put our variables inside f strings, sanitize float c, for example. But never mind. Here we have float result, which is equals just the sum of each of 3 curves. And as you can see, each of these 3 curves I multiplied by custom multipliers, actually without any variables, but just using these forward multipliers here. You can also calibrate them as you want. I will save these variables here, and then I return this result. So also about function setup noise. Here, as you can see, the implementation of this function, I pass these arguments here, and as noise I set seed, set frequency, set noise type, set fractal octaves. To see all noise types, as you see here, I use open simplex to see, but you can use anything. Let's click with control pressed on any of this sheet, and we can see inside fastnoise.h all of the variables, values you can use, all the functions you can use, and so on. And the last function I don't use actually because it doesn't work properly. I will work with it. Is actually smooth noise function with a box filtering algorithm. You can Google it. I will not explain because it doesn't work, but you can copy paste and try it by yourself or somehow improve this code. Okay. And what we see here, if we click F5, we should see some beautiful words here, and this building 5 actions with 4 processes or something like that is a good result. It means that there is no problems at this point, and it 90% chance we have 90% chance to start the project and play our game. Let's wait a bit. By the way, I don't know why we should wait a bit, because we don't change anything. I didn't change anything, I suppose. Okay, compilation finished. Our project is opening. You can see here how influence on your processor and GPU and RAM. And here what we should do before starting the game. Let's open public or private folder here in C++ classes. Click right mouse button on your chunk mesh or anything else actor mesh, actor class, actor CPP class file, and press create create blueprint class based on chunk mesh, and it will create something like that. Here, as you can see, we can change all the values we passed in .h file, like map size, grid spacing, UV scale, Z multiplier, noise scale, our material and curves in terrain curves category, and many other stuff. Here you should pass your curves before starting the game. It's important. Don't forget about it. And actually we can look at our terrain again. It looks nice. It's really nice. Let's even play. Here, for my convenience, I will show you for a minute what I did. Fuck this. This folk is beautiful, but so as you can see, we here have the large, beautiful terrain here. We have some lakes here, which we actually don't have any water, or plains represents water, but I just colorized this with vertex colors, and as you can see, it's almost flat terrain here, and it will looking like I mean swamp more than lake, but never mind. Here we have such inconvenient actually for moving peaks. We can smooth it by changing number of octaves, or for example by changing the frequency and make this terrain much bigger than now. And here, as you can see, in C++, we generate all this bunch of polygons once time, and the render range equals 20 chunks, and it really it looks really good. It really looks really good, and we have no freezes. But if you do the same thing in blueprints, you will just fucked up, because blueprint sucks, just sucks. It's almost 5 times slower than C++. And in the next tutorial series, we actually will work on optimization, multi-threading, and I suppose quad tree maybe, but it could take a bunch of time. I mean, like a week, maybe 2 weeks. so just waiting for this tutorials. I suppose you like it, and maybe if you will achieve some more good results, you can share it. Also, you can support me, just subscribing and putting likes and comments here, and maybe even better, you can just give me some money, because I just have no money. I'm a fucking poor Belarusian guy who wants who wants do some interesting stuff here. So as you can see, this terrain looks really good. We moving on this reached mountain, and I feel like fucking god. So we can see a lake there. We can see such a good peaks, so it's really good place to die. In future tutorials, we'll see how to create how to improve this terrain with 3D noise, how to add some maybe caves, maybe different holes inside the mountains with 3D noise, how to improve, how to fix these fucking edges and fucking lines in our terrain, and how to make this terrain looks even better. And of course, all other stuff like rivers, roads, and so on, we'll do it in later tutorials, and I hope you will glad to see it. But before, let's close this terrain, let's open our chunk BP class, and I want to show you one function that I don't use in CPP because I don't really need it, but it's really interesting. It's called domain warping, and what domain warping does, is actually changing the values of the noise and make terrain looks more realistic because it's less repetitive, I mean. And to do it, we have to get two values of the same noise and multiply our actual and multiply amplitude for x and y, and make sure that this amplitude is not the same for two noises by the output value of this get noise function. So as you can see, we have get noise function, we get from each of them output value and multiply it by x amplitude, and the second noise by y amplitude, and return x and y. And actually we can use this return this x and y as values for our third same noise, okay, to make this domain wrapping effect. And it actually, without other noises, can looks beautiful, I mean, but why we should use it if we can use just curves and different noises? It's more optimized, but not so interesting like combination of different noises. But domain warping is a useful function actually, and you can experiment with this function in your project. Maybe you will glad to see the result of working this function. But don't combine them with curves and other stuff, because domain warping looks good itself without any curves and noises. So, and the last thing I want to show you is how to create spectator camera. So for that we can just type right mouse button, create blueprint class, choose here spectator, I said, fuck, spectator camera or spectator pawn. Open this, actually what it is, spectator pawn. It's spectator pawn class. Here I just I don't remember if there is a movement component. If it's not, I add it. If it is, that's good. So here I get P keyboard button and get all actors of class third person character and get the first found actor and possess get player possess my controller inside this actor, and delay until next tick, destroy actor until after next tick, on next tick. Inside my third person character I do almost the same thing. I on press P keyboard button, I spawn spectator camera actor, spawn new actor, spectator camera, get world transform, get follow camera, get world transform, and possess my camera inside, possess my controller inside this spectator camera. So, and now I actually can press P and fly with camera, and press P again, and I will play for my player. So I suppose you are you were glad to see this video. It's long enough. I mean, like hour, I don't know. And it's interesting. It's really interesting. Experiment with these values. Experiment with these noises. Get your own values for these curves and just look at this. Just look at this and see the result. I recommend you to use C++. It's not hard to learn it, to be honest, and it's really good. It's really good. So let's we'll see each other in the next video, I suppose, on the next week. So have a nice day, guys. Goodbye.